Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 73 from the Smith Organic Chemistry textbook. This problem says treatment of compound C with phenylmagnesium bromide followed by water for its compound D. And we're given formulas for C and D. We're given an IR for D and then proton NMR for C and D. And we're asked to come up with structures for each of them. Okay, and so I'm just going to take this information a piece at a time and try to come up with these structures. So the first thing I'm going to do is an HDI for C. So it's going to be 2 times the number of carbons plus 2 minus the number of hydrogens, all of that over 2. So we have an HDI of 1 here. So that tells us we have 1 ring or 1 double bond. Okay. So then looking at the NMR, we have a singlet at 1.3 ppm with an integration of 6. And so I'm going to say that that's probably 2 methyl groups. So 2 CH3s. And then we have a singlet at 2.4 ppm with an integration of 2. Okay, and so this is probably a CH2. Both of these have no neighbors. So a 4-carbon molecule with a double bond or a ring and an oxygen in it. And this spectral information, the only thing that really fits here is this. So it's going to be an epoxide with 2 methyl groups. And so our first signal, this signal, is going to be these 2 methyl groups. So the protons on these 2 methyl groups. And then our other signal, this signal, is going to be the 2 protons that are here on this carbon. Okay. So then for D, so if we treat this epoxide with phenylmagnesium bromide, we would expect the Grignard to act as a nucleophile there and open the epoxide at the less substituted side. I guess, yeah, at the less substituted side. And so we should bear that in mind, but we should also, do the exact same thing here. So we'll calculate an HDI for this formula. So it's going to be 2 times 10 plus 2 minus 14, all of that over 2. So we have 22 minus 14 is 8 over 2 is 4. And so that 4 is entirely accounted for by the benzene ring. So phenylmagnesium bromide, obviously there's an aromatic ring there. And so that accounts for all 4 of these. So moving on, looking at the IR data, a peak at 3600 to 3200. This is an alcohol. So we have an OH. And that fits with what we were thinking, because if we open an epoxide, we're going to end up with an alcohol. Okay. And so looking at our NMR, so the 1.2 ppm singlet with an integration of 6, that's still going to be 2 methyl groups. So that hasn't changed. The 1.6 ppm singlet with an integration of 1. Might be the proton on our alcohol. So we'll say that tentatively and maybe come back and change that. The 2.7 ppm singlet with an integration of 2 is going to be that CH2. So the blue protons from C So they're still here in D, and so I think that's what that signal is going to be. And then our 7.2 ppm multiplet with an integration of 5 is our aromatics. So that last signal definitely tells us that we have a monosubstituted aromatic ring. So we can go ahead and draw that. So there's that. And then if we're going to work off of this assumption that C is correct, and so we opened that epoxide with a Grignard. So then that would look like this. So there's our 2 carbons. Here would be the alcohol. And then here would be our methyl groups. So again, so this first signal is going to be these 2 methyl groups here. The second signal, well, let's leave that alone. So I think that assignment is correct, but it's obvious which one is on the alcohol. So that second signal, or pardon me, that third signal is going to be these 2 protons. And then our aromatics are also pretty self-explanatory. So this structure makes sense. It makes sense with what we know a Grignard should do to an epoxide. And so, yeah, these are the correct structures for C and D. And that's the answer to chapter 20, problem number 73.